Hi geometry students, this is your post-test 4 video. We are going to be talking about radicals a little bit more today. So I want to just start with a quick review from Mr. Stock's video of how to reduce or simplify a radical, because really a radical needs to always be in simplified form. So let's take a few of these and do what we had already learned before. So let's take example 1. We have radical 75. Your job is to simplify that as far as you can. So the idea would be to split radical 75 into the product of two different radicals, where one of those radicals is a perfect square. And I'm just going to write a little list over here on the side of all the perfect squares just so I have them in my head. So 1, 4, 9, 16, 25. Hopefully you know where I'm getting these from. 1 times 1, 2 times 2, 3 times 3, and so on. So I'll just do a few more. So we're looking for the biggest one that goes into 75. So the biggest one we really have is 25. And 25 times 3 still gives you 75. So when you have that product, the radical 25 times radical 3, you can now take the radical bar off of radical 25 because it is equal to 5. And your simplified answer is 5 radical 3. Let's just try a few more of those and then we'll get into the new radical operations. So radical 45. Stop for a second and think of what two numbers would multiply to 45 where one is a perfect square. So hopefully you're at 9 and 5, which means your final answer is 3 radical 5. Okay, let's try the last two. Again, two numbers that multiply to give you 200, one of which is on your list of perfect squares. Now for that one you could go 25, but there is a bigger one. If I make my list a little longer, hopefully you can see that 100 would actually be the largest one that would go into radical 200. So that's 10 radical 2. And if you pick the largest one right off the bat, you won't have to do a two-step problem. And then last one, radical 50. So your final answer for that should be 5 radical 2. Okay, so we've done that already. Just a quick review on that. And the reason we're reviewing that is because now we're going to talk about multiplying, dividing, adding and subtracting with radicals. Okay, so multiplying, here's the rule. Radical A times radical B equals radical A times B. In other words, you can multiply a radical times a radical. Okay, so for example 1, radical 2 times radical 8 would be radical 16. Now the only problem with that answer is that it has to be simplified. Every answer needs to be simplified. That is just simply the number 4. Okay, let's try some that are a little bit harder. 2 radical 2 times 8 radical 3. So now you've got some numbers in front of the radicals. And the way you do that, you think number times number, radical times radical. Okay, so we're going to do 2 times 8, that's 16. And then radical 2 times radical 3 is radical 6. And before you box that answer, just take a peek at the radical 6. Are there any perfect squares that can go into that? And the answer to that is no. So that's already simplified. Okay, and then let's try two more that are maybe just a touch more complicated. 1/2 times negative 7 rad 5 times 2 rad 5. And I'm going to shorten up that word radical and just say rad. Let's do all the numbers together. So let's take 1/2 times negative 7 times the 2. Okay, so 1/2 of negative 7 would be negative 3.5 times 2. We're really back to just negative 7. Okay, and then radical 5 times radical 5 would be radical 25. Okay, so what is radical 25 then? Can we simplify that? And we can. That's actually going to be 5. So your final answer there should be negative 35. Number times number times number, radical times radical, and then simplify. And then one twist on that that you've actually already seen because we've done Pythagorean theorem and we've done a squared plus b squared equals c squared, but it's still a multiplying problem, is 4 radical 3 quantity squared. So think about what that really means. That means 4 radical 3 times 4 radical 3. So number times number, 16. Radical 3 times radical 3 is radical 9. And radical 9 is equal to 3. So your final answer should be 48. 48. Okay, so stop for just a second, make sure that sunk in. When you multiply radicals then, it's number times number, radical times radical. Okay, if you go to the back of that page, now we're going to divide them. And dividing is the inverse of multiplying, so it really shouldn't feel too much different. When you take radical A divided by radical B, that's the same thing as radical A divided by B. In other words, you are allowed to divide a radical by a radical, a number by a number, but not anything other than that. Like terms must be divided together. So if you take radical 32 divided by radical 2, that's radical 16. Okay, when you divide a radical by a radical, you're still going to have a radical. And then if you just take a second to simplify that, that's going to come down to the number 4. Okay, let's try one more. 12 radical 32 over 2 radical 8. Let's take the numbers separately. So 12 divided by 2 is 6. And let's take the radicals separately. Radical 32 divided by radical 8 is radical 4. And again, just take that number down a little bit at the end. That's going to end up with 12. Okay, and final one. Number divided by number, that would give you a 3. 15 divided by 5 is 3. Radical divided by radical is still going to give you a radical. That's radical 25. And take a second to reduce that radical 25 down to 5. Your final answer is 15. Okay, so take a minute and just look at that. Dividing radicals. Radical divided by radical, number divided by number. Okay, and the last thing we're going to do is we're going to add and subtract with radicals. So the deal here, the law, I guess, if you want to call it that, is that you may only add like radicals. And the fancy word for that is like radicands. So you can add radical 2's to radical 2's, you can add radical 3's to radical 3's, but you can't add a radical 2 to a radical 3. Okay, now these kind of look a little bit messier. So your first step with all of these is to simplify. That seems a little odd because we usually simplify at the end, but we're going to simplify the radicals because right now if you look at example 1, you aren't allowed to add those. Those are unlike radicals, but if you really think about that a little bit, if you take radical 8 and we do what we did at the beginning of this video, if we simplify radical 8 down into 4 times 2, which is really 2 radical 2, now I want you to look at that again. And I'm going to add one number, okay, right in front of my radical 2. If there's nothing there, there's an assumed 1. It's like x. If we see x, that's really 1x. Okay, so now look at that again. We couldn't add radical 2's to radical 8's, but how about now? Can we add 1 radical 2 to 2 radical 2's? And the answer to that is yes, and that would give us 3 radical 2's. Think about it as 1 of something plus 2 of something is going to equal 3 of that something. Okay, let's try a few more of those. So look at example 2. On the surface, it looks like you can't do a thing because 48 and 3 and 75 are all unlike numbers. But if you really take a second to simplify your radical 48, now minus radical 3 isn't going to go anywhere. And then if you take a minute to reduce radical 75, I think there might be something we can do at the end. So 48, 4 goes into it, but there's a bigger one. 4 goes into it 12 times. But if you think about that, another 4 comes out of 12. So if a 4 could come out and another 4 could come out, that really means a 16 could come out. 16 times 3 still gives me 48. Okay, now do that same thing with the 75. Think of two numbers that multiply to 75, one of which is a perfect square, and that will get you down to 25 and 3. Okay, take those little hats off of your radicals. So radical 16 is equal to 4 radical 3's minus radical 3, which I'm going to put a 1 in front of, plus 5 radical 3's. Now you're all set. Okay, now you've got like terms and you can go ahead and add them. If you have 4 of something, you're subtracting 1. Now we have 3. If we add 5 more to that 3, we actually have 8 radical 3's. Okay, so we're going to simplify, 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 and then add, if we can, the like terms on that. Okay, last one, and then it's your turn to work on your homework. Radical 45 plus radical 5 plus radical 8. On the surface, it looks like, nope, I can't add them. But again, if you take 45 and 8 and you do a little work on them, and by work I mean simplifying. Let me set you up a little bit here. If you just simplify 45 and you simplify 8, you should be able to add at least a few of those. So 45 is 9 times 5, and 8 is 4 times 2. Remember where that first number comes from? That first number is what we call a perfect square, and your perfect square is again on the side of your paper: 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. The list goes on forever. I always take it to about 100, 121, 144, just so you can always pick the biggest one. Okay, so if you go to 45, the biggest number that goes in there is 9. Okay, so that's where that 9 came from. So 9 radical 5 is really 3 radical 5 plus, okay, what should I put in front of my plain old radical 5? Okay, and that answer is a 1, plus 2 radical 2. Okay, so now did I make a mistake? Because the last one, all 3 of them came out to be radical 3's. Okay, so look closely. Am I okay with that radical 8? Radical 8. Radical 4 times radical 2. 4 times 2 is 8. That checks out. Okay, so for this one, you're really only going to be able to combine these two. You'll still get a nicer answer than what you started with. It just won't be as pretty as the last example. So if you have 3 radical 5's and you add 1 radical 5, you actually have 4 radical 5's. And then you're going to add to that 2 radical 2, and that is where you're going to stop. Okay, please don't do any fancy math and try to add radicals that are not like. That won't work for you. So 4 rad 5 plus 2 rad 2 is your final answer. All right, guys, your turn. Your homework has a little bit of everything on it. It's got some simplifying, it's got some squaring. Okay, you get a chance to practice that. Bring that to your teacher and we'll get you some correct answers. Thanks.